I changed something up there. Something that I built, like I touched, I handled, I designed, made it to space.
I truly just didn't see how we were going to be able to move forward, given that at the time we didn't have any mentors. The students who were involved just didn't have the support structures in place to help them be successful. I just didn't understand how this was going to even happen. And then I was their person in charge. Like, I didn't know what a CubeSat was. So yeah, there were a lot of struggles and a lot of dark nights where we're just like, I just don't see how this is going to work.
Thomas Jefferson High School in Virginia is known for its exceptional academic programs, but one after-school program is literally reaching for the stars. This group of brilliant students has been working tirelessly on a miniature satellite project, also known as a CubeSat, and they've just achieved a major milestone, launching their very own CubeSat into space.
My name is Kristen Kucko, and I am the robotics lab director at Thomas Jefferson High School for Science and Technology. The goal behind TJ Reverb was to compare radios in space. It was comparing Iridium versus the APRS radio.
An Iridium radio, which is a constellation radio. If you've ever heard of like satellite phones, it kind of harnesses that same system to be able to communicate in space. We also have an APRS radio, which is a amateur radio, which we also use to communicate with the satellite.
It started out as the Nano Satellite Club, which I think started back in 2016. And the goal was to build on the satellite that TJ had launched previously, which was TJ CubeSat, and that was run by Adam Kemp. And Adam Kemp was a teacher here a while ago, and he was actually the first person to have a high school launch a satellite into space. And so in 2016, another teacher took a swing at it. It didn't quite work out, I think, the way that everyone had hoped. He kind of transitioned on to something else, and then I picked it up in 2019 and saw that it was kind of in a shambles and tried to help revive the club. I just kind of used my resources, started reaching out to people like, hey, can you tell me more about CubeSats? That led me to one person, that person led me to somebody else. Then, we got some support from industry experts who decided to come in and help us. We created such a welcoming and interesting environment that even people from the industry who maybe tangentially knew about CubeSats, but wanted to learn a little bit more, they came in and started helping the kids.
The Nano Satellite Club stood out to me because they're putting a satellite in space. So I just thought it was awesome. This is so cool. They're building a satellite. I wanted to join. I wanted to figure out how is this happening?
Initially when I joined, I was like, there's no way this is a real satellite. Maybe we're just designing it and we're not actually launching it. But it turns out, no, we're actually launching it.
The project has been a true team effort with students from all grade levels contributing their unique skills and expertise. Some students have focused on the design and engineering of the satellite, while others have worked on programming the radios and analyzing data. And just like any team in a major corporation, they've organized themselves to leverage these skills to the absolute maximum.
Once we had built the program out more, we divided into different subsystems. So some would be the subsystem of communications, the subsystem of, CAD design for the physical components. Someone would be in charge of flight related hardware and software. So dividing it in terms of different subsystems within the satellite itself.
I joined the CAD design assembly team. So our goal was to come up with a good design for the satellite, the actual mechanical aspects, make sure everything fits. And when the time comes, assemble it, do documentation, get ready for spaceflight.
I mostly worked on software. So programming the flight software in order to make it do what it's supposed to do at the right time.
The first thing I had to do was write a driver method for our GPS. So basically just when the GPS would get more data, I would parse that and then send that off to the other parts of the satellite that needed that GPS data. So our attitude control, stuff like that. The part that was really cool about that was I would hook up directly to the GPS that we were going to use on in flight. And to do that, I had to go to this clean room. We had a clean room that was basically for basically just for stands with a plastic wrap around it, but then they had like an air vent inside to keep it like a pressure differential. And I just thought that was like super cool. Like it was a really kind of jank clean room, but like as soon as I walked in, I was like, wow, this is like super formal. This is like super high tech or whatever. And I would just sit right next to the like all the components that would end up being on the final satellite. And I would just like literally plug in my computer, start like looking at the data that the GPS gave me, and then just start coding for that.
So we're trying to do graduate level work at a high school. And it's not that this high school doesn't support crazy things like building a satellite. I don't think they just understand what's all involved in doing something like this. And so the limited hours, I'm a volunteer. Anything that happens after school is purely voluntary. It is not, I don't get paid to support this, or I'm doing it because I think it's important.
I remember like one of the big problems when I was when I finished my driver software and I started like integrating it with the entire flight software, was that every time we would finish like a component of the flight software, and we wanted to test it, we couldn't actually test it because there was something wrong with the hardware, or maybe like there wasn't like enough time to do it or something like that. As we kept hitting those barriers, we started like trying to develop like virtual devices or like simulations so that we could like have that like always available testing.
We needed a ground station, but that requires an antenna, and the antenna has to be approved by a lot of people in order for us to be able to install an antenna on our roof. So there's a lot of bureaucratic processes that weren't necessarily friendly towards our mission and goal that would have been, I don't think that other places probably would have run into the same thing if their whole goal in life was to put up a CubeSat.
Nothing came easy for these students. They had to rely on their own ingenuity and resourcefulness to overcome setbacks and challenges at every turn. What they lacked in resources and support from industry professionals, they more than made up for in determination, innovation, and teamwork. And what they've managed to achieve without those connections to industry like many other satellite clubs have is truly remarkable.
A lot of places have industry partnerships, which I was actually quite jealous of. Even the gentleman, Adam, who did the satellite for TJ beforehand, he had a partnership with Orbital. So he actually spent time at Orbital learning how CubeSats were designed and developed and how to build them. And I just wish I would have had that opportunity, because I think that it probably would have gone a little bit smoother had I had at least a foundational understanding of how this whole thing worked. But, we figured it out thanks to the internet and lots of friends. we got through. One of the other things that we did this year is we also partnered with Vienna Wireless Society, because one of the aspects of the satellite that we completely neglected last year, because we were in the midst of building it, was the ground station. We didn't pay any attention at all to the ground station because we didn't have an antenna, and we didn't have the capacity to deal with the ground station. So what we did was, at the beginning of the school year, we got about 38 kids ham radio certified with their amateur radio technician's license.
They have solved countless challenges like this with innovative solutions and at times just pure hard work and determination. But all their hard work had finally paid off. As they neared the launch date, the students spent countless hours fine-tuning the program designs and brilliantly troubleshooting last-minute problems, as they had done for the last few years.
I think the most amazing day was in July when we took the satellite to Texas. It was just so like, oh my gosh, this is actually happening. This is a thing. It's like, I'm going to be walking through TSA with a Pelican case with a satellite in it. I left my iPad at the X-ray because I was so excited about the whole thing that I just kind of like lost myself, getting the thing across the finish line. So, got it on the plane, put it underneath my seat, and got to Texas, like essentially just held it like a baby the entire time.
It was kind of nerve-wracking because, I've dedicated so much hours, and the entire team has dedicated basically an entire year's worth of work towards this project, and seeing it come to fruition was, I felt really proud, and I'm sure the rest of the team also felt really proud, but I also felt, really apprehensive of, is this going to work, and what's going to happen? Is it just going to spontaneously explode?
I was super anxious. It was crazy. And then you just start to push it to the back of your mind and carry on with life. And then the time for the launch came up, and again, the excitement starts to build. It was really amazing to me, because something that I built, like I touched, I handled, I designed, made it to space. Right? That was kind of emotional for me. I changed something up there. That was the biggest highlight of the launch for me.
So just to get an idea, the deployment was actually at 6 a.m. So everybody got up super early to be on the call to wait for it to happen. And, we were just, after launch happened, there was a starting sequence that took about 30 minutes to an hour. And during that time, we were just sitting on the edge of our seats waiting to receive something, hopefully a signal, sign of life from our satellite. But unfortunately, that did not happen right away, and it took a week for us to switch to our secondary radio to establish contact.
Getting contact was a bit of a challenge, but fortunately, the amateur radio community from around the world really came out to help us. We had a pretty big social media presence, but we put out some posts kind of explaining what was going on with the launch and how we weren't able to find it with Iridium, which was our primary radio initially. And amateur radio specialists from all over the world tried to find the satellite and made contact with it. And eventually we detected it digipeating from the ISS, which is one of the things that we had designed it to do. So we were pretty sure we found it, which is awesome, with the help of this whole community. And it was awesome to see that kind of come together. But there were a few weeks there where it was a little bit stressful.
So it's still questionable as to whether or not it's actually working. But we have a ton of SatNOG's observations that says it is. But again, we don't have a ground station, so we can't confirm it. So right now we're hoping that, sometime before the end of July, when it's supposed to deorbit, we'll get at least one solid confirmation that it was our satellite and that it did work. But the thing that was really interesting is that we did register the satellite with Space Force in their satellite database. And so we get conjunction data with it, all of the operator stuff. They got to learn about how the operations worked. We actually got a briefing from the Space Force telling us about the satellite registry and how that whole thing worked. So they're really getting an incredible education here because they're doing the whole process. They, most of the time whenever they talk about satellites, they think that the launch, it just ends at the launch. The rocket went into space. It's done. We're finished here. But they're realizing that it's not just launching the satellite; it's operating the satellite as well. So they're getting to learn that aspect of the business as well.
Projects that give full ownership to students and expose them to all these aspects beyond technical skills like project management, communication, and teamwork fosters a sense of curiosity and excitement that just simply can't be replicated in the classroom setting.
I can talk to them about satellites all day long. I can show them a really good curated video of how satellites are made, but there's nothing like putting the thing together themselves. I just feel like there's so much of education is very sanitized. It's just very what can I get done in a 40-minute period, and and cover the topic and move on. But you have to get messy. You have to get messy. You got to get in there. You got to do the hard stuff. You got to sit with the kids whenever things don't work out. When the Wi-Fi in the school shuts down and you don't know why for a month, and then all of a sudden you're like, well, I guess we're done. We can't do this anymore. And then we figure out a way to get around the Wi-Fi in the school to get it to talk to something and get it to work. Troubleshooting and going through those processes and making it normalized that things don't work out. It's never going to work out the first time you do something. Your first idea is not the best idea. Normalizing what that process looks like helps them become stronger builders. It helps them become more resilient in the face of things not happening the way that they had anticipated or they had expected. It makes them a more well-rounded student, and hopefully better off in the workforce because they realize that things aren't that easy. I think one of the things that I do when I don't understand something, when I don't understand something, is I don't pretend like I do, and that is probably, I think, one of the most beneficial things that I could have done for the students was just I don't know the answer to that. Let's go figure it out. And just having a really healthy understanding of, when I don't know something, I'm not going to pretend like I do. I'm going to go, use my resources, talk to people, reach out to the community, find mentors, find other people who do know those things, and not be afraid to go ask those people, what exactly have I gotten myself into?
I feel like that's the biggest the greatest thing about the Reverb team is that we all learn from each other, and we all have these specialties that we learn individually through our research and just trying out different things, but prototyping. These things that we learned can work most of the time. And then we teach it to each other, and we work with each other to come up with a better solution than each individual person had before. And that's how I learned, and that's kind of how I hope to teach other people.
One of the most exciting things about this club was the way that students were able to learn from each other. As they tackled these various challenges of designing, building, and launching a satellite, they discovered that each member of the team brought a unique skill and perspective to the project. This spirit of collaboration and learning led the students to write a paper about their experiences and share with similar clubs around the country. By exploring the experiences of other student-run satellite clubs, the students hope to gain insights and learn from their peers. This kind of cross-disciplinary collaboration and knowledge sharing is at the heart of the scientific process, and the students were able to put it into practice in a truly meaningful way.
We decided to write a paper where we reached out, sent emails to satellite teams from all over the country, high school and middle school satellite teams, asking them kind of what type of project they were doing, how they got there, what they were trying to achieve. And we found out we were practically the only team that built our satellite from scratch without using any type of kit. And a lot of other teams also had like mentors do the vast majority of the work, and the students were kind of there behind them. And our team, we basically did everything on our own using commercial off-the-shelf parts. And so that was cool because we also saw kind of how unique our project was and how big of a challenge, especially compared to other teams that we were facing. I guess kind of a mixed misconception we had before, it was kind of like, we are superior because we are not using a kit, might have been something that we might have thought like 3 or 4 years ago. But now we're like, okay, all these kids who are using a kit are also learning a lot. So our next satellite project, we're using more modular parts that are structured for learning. And that's kind of how that paper has helped us move forward, and being a part of kind of evolving our club to see how we go in the future has been cool as well.
And I think what the important part is, at least for industry, is understanding that you don't necessarily have to have a PhD to do these kinds of things. If you go and look at the types of jobs that are available to people who want to develop CubeSats, a lot of those, the minimum requirements are a master's degree in aerospace engineering. Well, I feel like there's potential for people to maybe get into these roles that may not have those degrees and still be successful. My goal is to kind of get the students connected with like internships that relate to space, or relate to satellites, or relate to communications. And I was surprised that even after Reverb being launched, we still really haven't gotten those connections that I thought we would, which is kind of bizarre because they literally have done things that PhDs and master's degree students have or have not done. And we're still struggling to get the kids connected with good opportunities. So, I'm hoping and I'm hopeful that in the future that something like this will be able to help open the door for them to continue their education in aerospace.
These are such bright kids, and they want to ask questions. They want to partner with industry. They just need to have someone there to be a mentor.
So we actually have a website. If you Google TJ Space, you will find the website, and that's how you'll find us. I'm on LinkedIn. Obnoxiously on LinkedIn, because I'm trying to spread the word. What the kids are doing, what we're trying to do here is just really important, really special, and I hope that industry wants to reach out.
TJ Space serves as a shining example, illuminating a path for a younger generation in this expansive industry. With unwavering passion, TJ Space aims to invigorate and instigate change, shaping a landscape where opportunities that were once exclusive to a small few are now at the fingertips of anyone that can harness the spirit of innovation. I'm Joe Calamari with Project Geospatial, exploring uncharted frequencies from classroom to cosmos.